All right, guys, let's continue with the next part. uh, 1 minute, please. Let me do some small change in the setting. Yeah. so, um, so what's the plan for today, right? So yesterday, guys, we was talking about the elastic load balancer, right? So, conserve wise, what exactly the elastic load balancer will do for you? Elastic load balancer is just a service name, or you can say a product name from the AWS, right? But technically, it is just a load balancer. And when we say load balancer normally come with a feature called reverse proxy. And what is the use of reverse proxy, plus what is the use of load balancer, I have discussed you guys in very detail, plus I'll showed you some demo also yesterday. Okay. But with the help of load balancer, right, whatever we have done yesterday, it was just a one single scenario or use case, or very commonly used or simple use case scenario, whatever we discussed yesterday. Okay. But today I'm going to show you very core, powerful, complex use case of the load balancer. And that use case is so much related to one of the great architecture, the way we normally architect our application in today's world, right? So technically I'm referring to one of the great architecture called microservices. Okay. So if you have an application that is running in a design of micro services, how we can use load balancer over here. Okay. So before I discuss this particular topic, I just want to tell you one small thing. Those guys who are, may first time you are hearing this term microservices, I can say in this way, nowadays the entire all the applications that you see on the internet, right? 99.99% guys applications have design, or I can say architecture, that they are following of the microservices, right? And obviously if applications is running on the microservices, we have to plan for their reverse proxy concepts. We have to plan for their load balancer over there, right? So what I mean by this, so my entire class today is purely based on the load balancer that will help you to do a load balancing or reverse proxy for your micro services. Okay, and guys, you can consider today's class as a bonus class, because as such in our AWS CSA training, right, we don't have a discussion on microservices. But I believe if you really want to use the ELB service from the AWS and really want to implement for the realistic world or the real world, then you should know how these components work together. To introduce some more feature of the ELB, I just want to demonstrate with some great use case and the scenario that is purely based on microservices, right? Okay, but don't worry. If you guys are new in microservices and what exactly we are going to deal today, I'm going to explain you everything from very basics. You will understand what exactly going on there. Okay, but ELB has some more feature, like cross zone stickiness, or maybe connection draining. So these are the small concept. On the while explaining you the other concept, I will cover those concepts also, what I was discussing yesterday. Okay, but at least you know what is the use of ELB and how it works. Very high level, you guys know. Okay, so let's start with the concept of uh, uh, ELB that will help you to implement the load balancer for your microservices. So to guys to understand what exactly uh, is microservices, and what kind of challenge you will face and how ELB gonna help us. So let me give you one scenario. By the meantime, let me log in to my console. 1 minute, guys, please. So let me log into my console. Okay. Guys, this I'm going to open one application, and I believe everybody know about this particular application over here. So this is the one of the application you guys know. This is Facebook. Okay. So as a user perspective, it is just one single website or web application running. Okay, as an end user, so I am the end user of the Facebook. Okay, and for me, okay, as a client of the Facebook, for me this is the one of the URL. Okay, of the Facebook or the application. For me, I can say this is one of my endpoint, and when I visit this endpoint, I can see this particular entire website. Okay, but if you talk about the Facebook technical guy perspective and the IT guy's perspective over there, for them it is not a one single application or not only one single team working behind it. Okay, there would be or it is not like this, because guys, you can see here it look like a website. Okay, or I can say web app. And because they are website or web app, maybe they guys might have created this website, let's say in PHP, even though they use lots of language behind the scene. Okay, but let's say they use PHP as a language, or maybe Python, C or Ruby as a language. Okay, but because this is the website written in one language, one code, so they have to host the code, and for hosting the code they might use some kind of web server. And guys, if you want to use a web server, obviously guys, you have to configure the web server in one operating system on one of the OS, maybe in EC2 instance in our example. Okay, in our AWS training. Okay, so let's think. So as a user perspective, it look like that they have one operating system on one VM. They configure the Apache web server, and they copy or run the entire code. Or I can say the host the entire code. And as a user, final client, we can see one web app over here, or website here. Okay, but guys, technically, if you try to go in more deep dive, Facebook is not the very small application, right? You guys know uh, the the scalability, or the uh, the the scale of the Facebook. Okay, so what they have done, not only Facebook, if you go to other companies also. Okay, what they have done. So if you see here, there's one box. If you see in the top, there's one box, and this box is search box, and pretty simple, you just type here and they start searching for you. Okay, and just it is not a small thing. Facebook has a huge data that is normally known as big data, maybe in terabyte and petabyte, where what you search here, they will go to entire data and search for you. And for this, they have to give lots of storage. Okay, maybe the storage maybe come from, let's say in our example, maybe come from S3 or maybe XYZ. Okay, so I'm just giving referring guys. Obviously Facebook might not using S3, but whatever we know till date in the AWS perspective, I'm just giving referring to those terms and those services. So they have some storage that managed by them, and on the top of the storage they have written some application, and the duty of this application, or the duty of that program or code, only to go to this storage and search whatever we are searching here. Okay, and for just only for this particular tab, they have the entire team working on it. They're the great core engineer for storage, their respect software, securities, application. They write a code. They try to keep on optimizing the search algorithms. Tons of things there. So entire team is working on it. And this particular application, only search application. Search application is working in the entire different web server or different operating system. Okay, so the entire operating system there only for running this application. Obviously, for this application, they have some web server or the app server over there. Okay. Similarly, if you see here, there might be some chat box here. So very independent operating system working, and this operating system running some app server or web server, and they host the application for chatting. Okay. So guys, if you try to divide this one big application called Facebook or Twitter or Google or YouTube, right? So for us, it is a one endpoint, one URL, one big application, all right? But internally, these application is divided into multiple not component, multiple different servers managed by different team, or maybe the guy who is managing the search program, they might be comfortable in Go language, so these applications may be written in Go language, and chat application may be, let's say, written in Perl language. Maybe whatever the thing you see inside your setting may be written, let's say, in Python language, maybe in Java, maybe in PHP. Okay, so every team whatever they're comfortable with, or which language they think this is optimized for that particular thing, they use that language to create the code. Okay, but my final say here is, right, is if you talk about this kind of application, right, again, Facebook is technically for the final user that we are, it look like one single application, one single web app. But behind the scene, if you try to dissect these guys, or see in as a microscopic level, I can say, right, there are lots of small services that deal with their respective individual features. Okay, so one entire code managing the chat, one entire code is helping you to search, one entire code is helping you to write the post, and xyz. Okay, and this not only the code or one single program. Okay, there will be lots of program running for creating the chat program, and this entire program for them, for their team, is a one app. This called chatting app. And this app is managing in one independent OS. And obviously, guys, there will be a lot of guys chatting and using this app. So again, it is not a one single OS running behind the scene. Okay, they are running with a maybe hundreds and thousands of different OS with the same application. So this is one OS, one more OS, second OS, third OS, fourth OS. So every OS are running the same application. Okay, and these application, guys, again, because they are the multiple OS running with the same application. Okay, so in the top of this, we also create a one separate load balancer for this guy. Okay, so what happened when, as a user, if you click on this search button, or on this chat button, so you actually connect to this load balancer, and this load balancer is only deal to balance the load between this OS, and these OS are actually, every OS has a one chat program. Okay, and let's say this load balancer have IP 100. Similarly, if you go for this particular application here, let's say this application is related to managing your photo gallery. Maybe again, they have lots of servers running behind the scene, and they have their own personal load balancer. So if a user want to access this particular resources or photo gallery or created studio, whatever you guys are using, okay, so they connect with their load balancer, and they will balance the load. Okay, something like this. So guys, very high level, if you talk about any of the application, they work in this way. But but uh, but the challenge here in this architecture, normally, let's say this load balancer IP for this application, let's say this is image gallery. Okay, has 200, and this is 100. Again, the same issue will come up. Okay, issue would be, okay, if Facebook come with a 10 different feature, every facilities, they have a different team, different load balancer, different hundreds of computer running, providing the facility for image gallery or chat, something like this. So again, Facebook will tell to their final end user and say and say, if you want to use chat, come on IP 100, but if you want to use image gallery, come on IP 200. Obviously, guys, nobody gonna like this kind of uh, experience over here. So what Facebook has done, okay, so one of the developer of the Facebook create one page in the Facebook, maybe you can say is a front end page, that look exactly like this is a front end page. They write this code in HTML language, or they might use some kind of JavaScript, something like this. If you can see the source code of the Facebook, so this kind of code, they written in JavaScript and HTML, they create this front end. Okay, and this front end page, and they provide only one front end page to the user. Okay, or one single applications to the user that look exactly like this. Okay, and they tell the user, if you want to do a chatting, so I am giving you this, where it is, 1 minute. So I'm giving you this search button or this chat button. Just click there and start doing it, whatever you want to do. Okay, just start using it. But behind the scene, when user click on the search button or chat button, this front end of the Facebook or front page of web app or home page of the Facebook, behind the scene connect to this load balancer on user behalf, connect these guys, get the data, send the data, and give to this user. So it's a complete magic of the programmer or the developer, how they connect. Okay. Similarly, if the user want to connect to the image gallery behind the scene this application. So finally, user has to, or final client has to only deal with, connect with one single web app or front end of the Facebook or maybe Amazon or maybe Google, something like this. This is the front end. Okay, but behind the scene, huge or hell lots of independent applications running. Every application is meant for one single thing. So their team will focus on that part much, their security, their storage, the optimizing performance. Everybody has their own responsibilities. Okay. And so technically, for the user, Facebook has a one big application, but for the Facebook, they are divided into small services. Okay, and guys, that is, guys, this service is known as microservices. Okay, so almost every button that you see in the Facebook, okay, maybe you see, I don't know, I don't use much, but maybe you see this post button, you created studio, maybe you go to advertisement panel, maybe you go to search, maybe you go to image gallery, maybe you go to like or live button here. So guys, for us it's so simple, just they give a live button here, but just click on the live, entire set of different team working for this live streaming. Okay, and they have their own router, own switches, huge, right? There's not a, for us it's a single button. Okay, if you like, we have single button, right? Whatever you do, POC and all the things, they have a single button, but lots of entire team or their own set of users working behind this. Okay, so guys, this is a very high level discussion about some of the architecture behind the scene. Okay, I just want to introduce you what is a microservice. So Facebook is big service, but this big service behind this scene actually running with multiple individual service, that is called microservices. Okay, by chance, guys, this class is not actually about microservices. It's a big topic altogether. Okay, very important topic. Told you almost every application in the world nowadays or from last couple of years purely working on the microservice. Lots of reason we have. Okay, so by chance, if you guys wanted to learn actually about microservice and how we implement, how we configure, how we create a design pattern, tons of thing in the microservices. So guys, by chance, you guys might not, just want to tell you one more time. Okay, we have recently launched one program in Kubernetes, or official program is called CKA plus the developer track CKAD, because we introduced after CKA developer track, or because it is a developer track of the Kubernetes. Okay, Kubernetes. So maybe by chance in the developer track they don't have so much about discussion about microservice, but from my side I enhanced the topic, I add some extra bonus topic. So in my CKAD training, we are going to discuss a lot about microservice, how to configure, how to set up, and almost all the design pattern of the microservices we are going to discuss. So it's a huge training. Normally we have CKA associate architect training normally available market. Developer training is not so much available, even though they're available, but they don't focus a lot in the core designs pattern or microservices, other things. But I'm going to indeed introduce lots of things about microservices, plus all the things about to admin and the developer track we are going to cover there. Okay, so you guys might know, and 5th January we are starting this training, long training, global uh, global training, but it's cover almost everything about the Kubernetes. Okay, but for today's class, knowing this much knowledge of, at least you know high level about what is microservice, might be enough. But why you should know this concept? Because Okay, if you talk about if you talk about the Facebook front end web app developer, and say how you actually connect these microservices from the front end. Okay, for example, if any user any user click on the search button or click on this chat button, right, how you connect. Okay, so technically how you connect behind the scene. Okay, so are you using a different IP over here, like IP 100 or IP 200, something like this, or some other approach you are using? Okay, so there's a very typical approach, guys, normally we use. So for to explain you, let me create one more diagram here that will give you what I'm talking about. Okay, so let's say let's say there's two different OS running, OS 1 and OS 2. This I have IP1, this is having the IP2. Okay, and these are two independent OS. They are running with the two different web server. They have their own web server, or maybe they have app server or other company product web server. Okay, and in this web server we have hosted we have hosted uh, sorry, one application here, and let's say this application is purely for the chatting. And this app server, guys, we hosted one other application, let's say application 2, and this application is purely for searching, for example. Okay, so this OS managed by different team, this OS may be managed by different team, or maybe same team, but they are the independent server and the application. Okay, now right now for the client perspective or the final user perspective, all right, if you want, sometime client will connect this guy, sometime client will connect this guy, but understand one thing, client is not interested to connect on your IP, or they to know your IP, and we also not interested to tell the client IPs, to our IPs to the client. We are interested that client will connect to our chat app, or we are interested the client will connect to our search app. That's what we are interested on. Okay, so whatever IP we have, whatever language we use, whatever web server products we are using, so that is not so much interesting for our company business or the client user. Okay, but whatever interested we are on this application or in this application. Okay, now here, because there's two independent team, two different server, okay, or they have a different applications, right, and I want my client will have again one more great user experience. Clients don't have to write remember multiple IPs, IP1 and IP2. It is something like this. If you have 10 different features in your company product, so I don't want 10 different IPs to use. Okay, so what I want again one more product in between. Okay, and this program and this product, how it gonna help us. So obviously, guys, this program will have one fixed or static IP, let's say IP 100. Okay, and we'll tell our client, client, do one thing. Do one thing, if you want to connect to my company, and my company by chance has two different applications. Actually we say this application as a microservices. Okay, as a high level. Okay, so I'm giving you one single IP. Okay, and when you reach to this ip, you have to remember just one single IP. Okay, you don't have to know about this IP, or I told you according to my last diagram, behind the scene they might be have hundreds of system running with chat application, so you don't have to remember all the chat IPs or chat server IP. Okay, you just have to remember one single IP, and according to this example, you just remember facebook.com, just one single IP. fb.com. Okay, but what happened when you come to this IP? Okay, this program, either they connect to this computer, either they connect to this computer. And understand one thing, guys, by chance it is by in this diagram is showing one single IP, but you can think it is not one single IP. Behind the scene, lots of IP, 1 2 3 4, depending, guys, how much chat is going in parallel, how much client is connected in your chat application in parallel. So so technique is not one. To make it a little bit simple, I just put one. So one, this IP is a group of chat applications and chat server. This IP2 is a group of search application and search servers. Okay, so so this program say you don't have to remember all the IPs or web server, or sorry, search server or the chat server, just remember just one program IP called 100. Okay, but my program won't able to know how my program, how they able to how they know which application you are interested on. Okay, so you as a client have to tell one more thing. Okay, the thing is, when you come to this IP, okay, I am giving you, for example, the IP is, let's say, 10.0.0.100. You come to this IP, let's belongs to this program, and when you come to this IP, tell this program one more thing. Okay, and I'm giving you one name, some tag. Okay, so tag something like this, just right after this, let's check. Or maybe after the IP 100 again, guys, IP is fixed 100. I'm giving a tag for search called search. Okay, so give me this tag, chat or search. Technically, for the client perspective, it is a one URL. It is a one URL. But for this program perspective, this is the IP of that program, and this program I'm talking about, and this is the tag name, I can say. Okay, so this tag name afterwards, whatever you write here, okay, will help this program to decide which application my client is interested on. So if the client writes let's chat, okay, so my this program will connect to all the group of IPs that belong to chat. Okay, or maybe chat belongs to one computer, or maybe maybe have lots of computer over here. Okay, so they connect to this chat app, or I can say they will connect to this target. A target is what, chat. Okay, and by chance chat might be one or maybe hundreds of computer, the way I explain you here. So that is reason, guys. Normally we use a term called target group. TG. Okay, so I'll tell my program I'm going to give you one target group that might have one computer or 100 computers. Okay, so you have to connect to these group of IPs, and they have the internal load balancer. They will help you to kind of IP1 other chat program the way I explained you in this example. Okay, but if my final client or final user write this URL, for the user it is just a URL. And guys, by chance, if you know a little bit about web server, normally in the URL, if you type slash serve or slash chat in the last, so it look like for the user that is a file name or program name or the folder name. Okay, but technically for this program, okay, they are just a tag who differentiate which group of computer want to connect. So when this tag come to this program, okay, or maybe for the user perspective, I can use the sum. This is the one of the path, I can say. Okay, so when this path come to this program say, hey, because you're looking for this path, so I will, now this time I will connect you with this group of computers. And this group of computer may be one single computer, maybe hundreds of computer. So that is it, guys, this is known as a target group. So I will, guys, connect you with this target group. Okay, and they will automatically manage the internal load balancing. If they have one or two, then if you have two, they will start doing their own load balancing behind the scene. Okay, so technically this program is, by checking this final tag, they are actually, what they're doing, they are routing here. So either they route the packet here, or either they route or give the connection to this application, they route here. Okay, so technically this program is doing a routing either here or here, based on this tag, based on this path. Okay, so so that is reason, guys, it is known as path based routing. Path based routing, sorry, routing. Routing. So this program has a one interesting capability. So when any user come to this program, okay, obviously this program should have IP 100, otherwise they won't accept the packet. But when this URL come to this program, they always check which path you come for, come to us. And sometimes, the guys, this path is also known as just route. So which route you come to us. So program say, because you come for slash chat or chat route, and my chat router belong to this target group, or my chat router belong to or associated with or I can say registered with this target group. So I will connect to this system computer and what application they have, you can connect. Okay, so technically guys, in this whole scenario, okay, by chance, one more small thing just for your knowledge. Okay, normally client guys don't type ip and the route, we don't type. Okay, that is a reason, or that is a reason our front end developer has create all the route for us. So technically, if you go to Facebook, if you click on this in this chat button, so when you click is, so developer has used some kind of if you guys by chance know web technology, so they use some kind of a synchronous call that's called ajax call or javascript call. Okay, call means they have a url, and that url actually connected to uh, this one, this one chat. And when you click on this search, so you don't have to type, they will connect to connect to one of the url that is something like search. So technically normally client don't have to connect, right? And again, they don't have to remember. For example, we have 10 applications running, 10 features, we have 10 microservices we have. So client has to now don't know slash chat slash search slash people slash settings slash account, maybe inventory. Okay, so we normally give a client or my final user or my community team members one front end application developed by one of my developers, web developers, and they give to us. So they say just remember one big name like facebook.com, but just remember one big application. And this application, I'm giving you clickable button, click here, click here, click here. They will connect you to the respective services. Typically, that service is the microservices. So again, guys, we are not in the program. Okay, by chance, anybody who is following me in my IISc Rise Python classes, that's free, of course, obviously. So there we are going to talk a lot about web technological development. So this kind of application we are going to develop from the scratch in my training, because here we have to use API and hundreds of things we have to use. So that this here, guys, we don't have to discuss in AWS about the development part, but I just want to give you the internal concepts, how the things connected to each other. Okay, but if you are developer, you're creating this application, you can create the code, you can connect the dots, but the load balancing part, as a developer, you can't handle. Okay, you have to use or not load balance, actually I can say this. Where is my diagram? This routing, path based routing, you have to use certain program in the market. Okay, and normally guys, the path based routing is normally come by a program that is known as load balance. So, if you talk about the next generation or the newer load balancer, okay, so I will say is newer load balancer because they have a capability of to deal with path-based routing. Okay, path-based routing. Okay, they can deal for you. So technically, if you use a program again in the AWS, if you use ELB as a load balancer, so ELB has a feature for path-based routing. Okay, path-based routing. Okay, and guys, if you remember, this diagram is little bit same like yesterday diagram. Okay, but the difference is in this diagram and my yesterday diagram, the difference is if I very quickly draw the diagram what I drew yesterday. Okay, to give you a very quick difference. So yesterday, guys, I also created something like this kind of diagram where we have final client or the user. When the client want to connect, they will connect to one program, and by chance the name of program that I given to you yesterday is called load balance. And this program will connect to IP1, IP2, IP3, something like this. Okay, so this is IP1, IP2, IP3, and all the guys are running with the same sorry, same application. Okay, but client have to remember only one single IP100. Okay, and somebody come on the IP100, either they connect to this guy, this connect to this guy, they connect to this guy. How? Load balancing with the reverse proxy concept. Okay, but if you guys understand this thing, right, how my load balancer come to know. Okay, if client come on IP100, come on 100, we have to connect to IP1, we have to connect to IP2, and we have to connect IP3. How they come to know? Because there might be possibility in this kind of setup we can do. You might have two more server here, that is IP4 and IP5. Or there might be possibility this three IP is running with the web server 1, web server 2, web server 3, and maybe this two system is running with the mail server, for example, mail server 1 and mail server 2. So it's a different server altogether. And obviously, what I want, I would like to use IP100. Let's say I have one single load balancer, and I want if anybody come to this load balancer, they will connect to this guy, this guy, this guy. But same load balancer I want to use for one more purpose. If somebody come to this load balancer, again on the same IP, I would have to connect this guy and this guy also. Okay, this guy also. So for this, can you do this thing in ELB or on load balancer? Somehow you can achieve this. But what I'm trying to explain here is, okay, how your load balancer here, in this case ELB, come to know if some client is coming. Either we have to connect to these guys or we have to connect to this guy. Okay, so according to my yesterday example, guys, they are using a concept called port number. I told you guys yesterday, whenever any client come to the ELB, they come to this IP with some port number also, like 88. So we can write one rule in my elastic load balancer. If somebody come on your IP, sorry, port number 8080, it means they are, or you have to connect with either IP1 or IP2 or IP3 on their port quality. So either you connect with IP1, IP2, IP3. Okay, but we can do one more thing in the IP100. We can start one more port, let's say 1, 2, 3, 4. Okay, and we can try to write one more rule in my ELB. If somebody come on this particular port number, in this particular port number, then you have to connect to either IP4 and IP5. Means actually my client wanted to connect, or maybe somebody had written some JavaScript application, they want to come to the mail server. So you have to connect to IP4, IP5. Okay, so normally and typically or traditionally, I can say your load balancer always route the traffic or reverse proxy the traffic by looking at the port number that is provided by the client. And that is the reason, guys, your elastic load balancer has to start some port number. And that is the reason we use the term called listener here. They to start some listener. So we can start one listener and say if somebody come to this port is listening, connect to this guy, and this guy. If somebody client come to this port, you start listening this port also, but internally you have to connect or route either to this IP and this IP. Okay, that's what also you can do. Okay, so guys, this is the very typical nature or the behavior of any load balancer in the market, where they decide where to do a reverse proxy and do the load balancer by checking the port number provided by the client. So if you guys remember yesterday, very quickly, if I show you, because our load balancer is still running. Okay, so if I show you very quickly here, so this is the one load balancer we had created yesterday. And guys, the load balancer, whatever we created yesterday, was very typical. Typical means the traditional one. I'm not saying outdated. I'm saying this is the way we always use the load balancer. And what we did, we'll tell anybody who come to this IP of the load balancer, according to my example, this IP is 100. Okay, but load balancer, you come to my IP, but how I know which backend server you want to connect? You want to connect IP1, 2, 3, this backend server, IP4 and 5, this backend server. Okay, so that is decided by a listener. My listener will decide. So if you see here, guys, when you create this ALB, you have also configured one listener here. This listener was very clear. They say if anybody come to my load balancer on this port number, we will connect to my backend instances who are running with port number 80. Okay, and these are the backend instances we are running over here. Okay, so we will connect to, so anybody come on this port, we will connect to these IPs. That is a reason. So whenever the client want to connect, okay, to the backend server, they type the load balancer IP, for example, IP 100, and they type port number 80 of the load balancer, and load balancer accordingly, guys, to the reverse proxy plus the load balancing here. Okay, that I will explain, but that is the guys meaning of the relation. Okay, so by chance, guys, in the typical load balancer, okay, listener is the one who help you to do a reverse proxy and have the proper other connectivity, or check the rule, actually I can say, okay, which IPs we have to connect, something like this. But typically in the load balancer, guys, listener normally work with the port number. And this is the very default common behavior of the load balancer. That is reason, guys, this kind of load balancer is known as old generation load balancer. And in the ELB world, in the AWS, okay, if you want to use a listener or the load balancer, they will check the port number, and according to port number, they decide which IP backend server we have to connect. Then we have to go for classic load balancer. Like if you remember, I told you yesterday, there's three kind of load balancer we have. Very quickly, let me show you. Okay, so if you create one more new load balancer, okay, so I'm talking about this load balancer. So this is a previous general load balancer, and this load balancer, guys, work on the port number. Okay, and guys, by chance, by chance, if you know about networking, so in the networking we have a OSI model that has a 7 layers. Okay, and if you know layer 1, layer 2, layer 3, layer 4, 5, 6, and layer 7. Okay, so if you guys know about this layer, layer 3 is known as network layer. Okay, layer 4 is known as transport layer, and layer 7 is known as application layer. Okay, so what's the difference between these three layer? So if this is the one computer, this is second computer, A and B. Okay, and if A is sending some packet to B, okay, so whenever, guys, you create a packet that's go to a network, every packet will have this total 7 layer. Either you use TCP or UDP, any other protocol, they always has this 7 layer. So what the meaning of this layer? Okay, so in this packet they include layer 2, layer 3 information, layer 4 information, layer 7 information, other information also. And when they reach to B, and B say, in your packet there's lots of thing, lots of information. And guys, typically if you talk about the packet, there's a two main information we have. One information is called header, and one information is called your main data, maybe login name, password, chat data, something like this, mail data. Okay, but if you talk about the header, normally header is the one who contain almost all these information. Okay, layer by never go, but yeah, all this information they go in the header. So B say, I'm going to receive this packet, but before I use your data, do something on your data, I will go to your header, and I am only interested to look your transport layer. Okay, or I am only interested to look your network layer. Or I am only interested to look your session or presentation layer or application layer. Okay, why I have to look? There might be hundreds of reason, but accordingly I will take some this. Okay, I will revert. I'll use something here, or I will do something on the data. Okay, so if your B is the one who are going to use this packet, obviously they have to, because A will sending the data to B. Okay, and B say, I'm obviously, guys, if somebody sending the packet to you, you should have one program running, and this program is the one who are going to access this packet and going to use this packet. But this program say, for accessing this packet, I will check your header, and from a header I will only check your network layer. So I can say this program is a network based program in simple term. Or this program is a transport layer. If the program use layer 4, I can say transport layer program. If the program is checking your 7th layer, that's called application layer program. or application based network based program. I can say. So I'm not going to explain you OSMR is a long model, tons of concept we have to discuss to understand this, but I'm just going to referring you why I'm going to discuss you here. So in the networking world, if you have a program and this program has a duty of reverse proxy, or I can say a load balancer. Okay, and load balancer say if some packet come to me and my duty is to do reverse proxy, and my duty is to is to is to do a load balancing. And for doing load balancing or reverse proxy, I will only check the network layer of the packet, or I only check the transport layer of the packet, or I only use the application layer of the packet. Okay, so these three capabilities your load balancer have in the market. Okay, but if a program say I will only use layer 4, and layer 4 is a transport layer, normally TCP and UDP protocol come here, and all the port number normally come in this layer. So I can say this layer, load balancer is based on transport layer because they check the port number, and that's what guys exactly happening here. So the typical load balancer we use till date is a classic load balancer, right? They only check the port number. They only check the port number, and according by checking the port number, they do something with the packet or with the data. Okay, so all the normal typical load balancer, even though guys you guys might know maybe HA proxy maybe. Okay, that is also by default kind of transport layer based load balancer because they check the port number. Okay, but there's some load balancer. Okay, they don't check the port number, they use just network layer to the do a load balance. It's called network based load balancer. Okay, and this load balancer guys is again provided by ELB, and this called network based load balancer. This one, NLB, network based load balancer. Okay, and there's one more load balancer we have in the market. They will go till the layer 7, this called application layer. Okay, and accordingly they take the decision. Okay, that's called application based load balancer, or by chance in the AWS they have the same name, application based load balancer. Okay, it's called ALB. Okay, now, guys, I don't want to discuss much. I know if you guys don't know about OSI model, you obviously won't able to understand about this layer because I haven't explained you properly because I don't want to invest my time over here. But maybe in my some of other networking classes, I will definitely discuss about this layer. One of my favorite topic. I normally when I used to take the Cisco classes, I normally explain very proper way, but I'm not explaining you right now. But just one small thing I just want to tell you. If just very important topic in information here, if any program, maybe load balance is one program, if they want to use and see transport layer, because this layer will come after layer 3, so they have to go through via network layer. So you can't directly jump to layer 7. You to go to layer 1, then layer 2, then layer 3. Then after layer 3, inside the layer 3, we have layer 4. Inside the layer 4, we have layer 5, something like this. Okay. It means it means if some program, all right, is only looking in your packet header till layer 3. Okay. So they don't have to go to other layer to see other things, other information. So that program is always super fast. The program is want to go to layer 4, so they have to go again one more next layer, so they become a little bit slower. Like if they go to layer 5, layer 6, layer 7, so any program they are going to till layer 7, they are comparatively very slower. Okay, so if you think your program or maybe your load balancer work super fast in the terms of routing or reverse proxy. Okay, so always your network based load balancer is very much useful. If you want a fast speed, great performance, or I can say very less latency. Okay, so network layer based devices or network based or load balancer is always the great choice if you want to have a great performance. And that is the reason, guys, if you see here, network load balancer is used for ultra high speed performance. Ultra high speed, millions of requests per second. Here in this case of AWS, they can do for you. Okay. For this, you have to use network based load balancer. But if you are concerned, not for the speed, maybe you're concerned, obviously we always concerned with the speed, but if you want to take some extra decision, okay, extra decision, and one of the decision is this one. Decision, where it is, this is one. So you want your program or elastic load balancer, okay, will look one more thing. When a packet come up, so client and user, or maybe the front end application, going to add some path name here and some route name here. So guys, whenever you type anything in the last of your IP address in the URL, like URL is something like this: http colon slash slash, then IP address, and after IP address, whatever you type, normally known as path. Okay, so this path information, guys, or this path information always come inside the packet, inside the packet header, and they belongs to layer 7, means the application layer. So if you want any program, go to your packet, go inside the header, go inside the header, and look for this information. What client has typed? They type slash chat, they type slash search. Then program should have a capability to go to till layer 7. And obviously, if they go to till layer 7, the over program would be slow, because every packet we have to go, they become slow. But we have to go because this is the only layer that contain the information of my path. And not only path, there's a lot of things there. Anybody who by chance know query string. So if you guys following along my Python classes, we talk about a query string. Okay. Or maybe if you know, guys, about cookies or sessions, and lots of things there, some kind of other variables of HTTP protocol. Okay. So all this information always come in layer number 7. So if you want, your program will go and read this information, maybe cookies, maybe sessions, my query strings, some other information, maybe you had the path information, right? So that program should have a capability to go to layer 7. And obviously they go to till layer number 7, the way I explain you. They can't directly jump, they have to go via this route. Layer 1, they, you can think is encode, then a layer 2 encode, layer 3 encode, layer 5 encode, and they go in deep inside to the layer 7, then read the info. So overall thing will be slow. It will impact definitely performance. Okay, but we don't have any other choice. We have to go there, right? Because without going there, how I can see what client has typed, which path, and without knowing this path, okay, how I can tell my program, okay, what path they type slash chat, they type slash search. And without knowing this path, how my program will do path based routing, how they help us to connect either to this target group or this target group. Okay, and that is a reason, guys. That is a reason this kind of load balancer obviously is a program are known as application based load balancer. So guys, we see here this application load balancer, I don't know they have written this information or not, because the core concept of networking. But if you talk about this application load balancer is great for microservice, and the container means I'm talking about Kubernetes or Docker. And guys, today's entire world, applications is hosting on the container management services like Kubernetes or Docker or something like that. So there, this is one of the great applications. And if you don't have any application load balancer, so working in the today's services or microservices, or I can say, like just example, Facebook, impossible. Okay, they won't see what client has written, what route they have written, so they can't take the decision where we have to route. Okay, so guys, lots of information I'm trying to give you. As such, there is no requirement in the AWS training, but I think it's always good to know this information. Okay, especially nobody talk about actually what is the meaning of actual meaning of application load balancer and how they work. Okay, so I can say this application load balancer work on layer 7, network load balancer work on layer 3, that's called network layer. Okay, and classic load balancer work on layer 4, that is a transport layer where they see the port number. That is a typical behavior and old generation load balancer we have. Okay, but in the microservices I told you, I told you if you want to do a advanced routing, typically here what they're trying to tell you, if you want to go for path based routing. And path based routing, guys, is not the only thing. There's lots of things more and more you know about application development, like cookies or query string. Right, you come to know there's lots of things we can use to decide where to route. Okay, so lots of things we can decide. Okay, so maybe I don't know, they have they have written, at least this diagram guys give you the idea. Okay, so this is the same kind of diagram written. So when anything come in the load balancer, they see the rule and they send to one of the target group and the rule. And the rule here is slash chat or slash search. Okay, so similar kind of diagram they have created over here. In the OSI model, I don't know have they written this information or not, but here we are talking about path based routing. Okay, path based routing and lots of other routing you can also achieve here. So this is a documentation from the AWS. But I think I see a very high level information I have given to you. But the final conclusion is in the simple term, if you have a microservice that everybody has, and if you want to give only one single endpoint to the customer, that is the way we always work. One of the simple example is facebook.com is a one final endpoint for the customer. Okay, but behind the scene every part feature component is work in different servers. Okay, typically this is called microservice kind of architecture. Okay, then we need some program. This program is more, maybe load balancer in this example might not be good name, but this program is a load balancer program that has a capability to do a path based routing. And for this they have to look to the application layer, means layer number 7 of your packet or the header. That is not important to know by chance, but it is the way they work. Okay. Very interesting topic, guys. I highly recommend, just go deep dive into network. I've done hundreds of means research about the networking. I go very deep dive, and I've seen literally how the thing work, create our own code, create our own packets. So very clearly I know what exactly behind this thing. So I'm trying to give you some of the information from my knowledge, but otherwise it's not so much important to know over here. Okay, so there's this kind of setup we are going to do. So we are going to create our load balancer. That's called one of the part of the ELB. That's called application load balancer we are going to do today. Okay, so let's implement this part. But if you want to create a application load balancer, it is one of the type of elastic load balancer. Elastic load balancer is just a service name, contain 3 load balancer: classic, application, and the network. Today we are going to do with application load balancer, and one good use case is microservices. It's one of the good use case for this. So guys, let's start building this load balancer. So for today, what I'm going to do, what I'm going to do, again, let me start from here. So guys, I'm just showing you the diagram that is that will be our practical. So this is the practical based kind of diagram I'm going to create here. So we have one VPC. Inside this VPC, right now, guys, I am dealing everything with single zone. But when I go for cross zone, I will add some more component here. So we have one single zone, and in that particular zone, and obviously you guys know that zone, one single zone is managed by one subnet. So this is my one VPC. Here we have one single subnet running in one of the zone, maybe let's say one data center. Okay, and what I'm going to do in this subnet, I'm going to launch by chance right now one single operating system, OS1, and one more operating system, let's say OS2. And now this time, guys, think this is the one of the microservice. This is the one of the microservice. This microservice may be managed by different applications. Let's say they manage the chat application, and this microservice may be managing search application. Managed by different team, maybe any of the language they use. Okay, but I don't want to give different URL IP1, for example, IP2 to my final customer. To final customer, I want to present a one single application like Facebook. So for this, I put one load balance here. Typically, it's called routing path-based load balancer. It's called application load balancer. So what I'll do in the application load balancer, I will tell my load balancer that I'm going to give you and I'm going to create one listener. Listener. Okay, and today my listener is okay, means if any client come to you, you have to listen. And guys, obviously if somebody coming directly to layer number 7, you can't bypass layer 4 or layer 3, and the other layer also work behind the scene. Okay, so if you say if some load balancers are working on layer 7, they should have transport layer, means they have port number. They should have network layer, means the network layer guys contain the IP addresses. Okay, so you tell to the ALB, can do you have layer 3 information, means IP address? Yes, say I have one IP address. Do you have any layer 4 information, means port number? Yes, say we have port number. So guys, whenever you launch ALB, they will give a public IP to you. Okay, and you can decide your own port. Let's say yesterday I decided 8080 port. So these two information are given to you. But I tell you, I'm going to tell my ALB, because your application load balancer, you're not taking the decision according to port number. Okay, because whenever any packet from the client as a request, you have to decide where you want to send. You want to send to the IP1 or IP2. Okay, to taking this decision, okay, we have to create one table. And the table we will write, if anybody from the client come to public IP, let's say your public IP is 100. So anybody who come to IP 100 on the port number 8080, but that is not important. The important is after this IP and the port number, if they write some path and the path they write /chat. If this is the case, then you have to do a reverse proxy and connect to IP1. IP1. But if somebody come again on IP 100, the same port. If you see here, now IP and port number fixed. But if they type, find the client type, or maybe we have provided some kind of front-end application of JavaScript or HTML, if the type /search, then you have to do a reverse proxy and connect to IP2. Connect to IP2. Okay, so I'll tell my ALB load balancer. Now you don't have to listen only the port number. Now your listening would be based on the path also. Okay, and typically, guys, this table is known as policy. So we have to create this policy in my application load balancer. Or because they are application, and this information I told you guys always from the client packet come in the layer 7, means application header. So now ALB has a capability, go till this layer, read what they are sending, what request they are asking for, and my ALB will take this decision accordingly, either send to IP1 and IP2. Okay, that's what do. And now the interesting thing is, according to the load balancer, now they are not so much concerned about who is managing this OS, which team is managing, which applications server or web server using, or which language they have written the code. Whatever the language they have written the code, that is not enough. That's not important for me. For me, I am the application load balancer. For me, the important thing is we should have give a final connectivity to the client according to what exactly they requested. And we are not giving a different of IP and the port number. One single IP, one single endpoint. Okay, they are connecting with multiple feature or the microservices, something like that. Okay, so in the ALB, we are going to create a listener. Again, it is same listener, but if you see, guys, in my last load balancer, this is CLB, older one. Here, the listener, here the listener is if you see, there's no rule here, there's no policies here, there's no option to add a path or HTTP header or cookies. Lots of things we can add here by taking the decision, or string, query string. Okay, nothing is there because they doesn't support this. They only support port number. Why? Because they are transport based, layer 4 based load balance. Okay. So, but if you want to take this decision, normally in the microservices, you have to go for application based load balance, and that's what we are going to deal today. Okay. So to demonstrate this, guys, what I'm going to do, but by the way, I just want to tell you one more thing. Okay. By chance, in this example, my backend server is running with one single IP, but I told you guys today, okay, there might be lots of computer running with the chat server. Maybe IP, let's say IP 100, IP 100, let's say computer A, computer B, C, D, E. So these are the independent computer running the same application. Okay, why we want to run multiple computer with same application? Because of the load, right? So here the meaning of load balancer coming. Okay, so we have tell my ALB, anybody who come to slash chat, okay, connect to any of these computers. So behind the scenes somewhere here, they actually put the typical load balancer. It's not visible, but actually behind the scene they put it. So my ALB will send a request to this load balancer, and this load balancer will kind of add this guy, this guy, this guy, this guy, this guy. Like all the guy has same code, same application of chat. They will connect all the guys with the load balancing part. Okay, and that is a reason. That is a reason. Okay, these computers for my load for the ALB, these are the target. So this all the group of computers is known as target. Now it is your choice in that inside target group you want to add one computer or 10 computer or maybe thousands of computer. But in my case, in my today's practical, I'm going to only use one target group. Sorry, one computer inside this target group. Similarly, here they might be hundreds of computers here. Okay, so this is one more target group we are going to configure today. Okay, but in this target group again, I'm going to add only one single computer. Okay, so this would be some of the practical. So technically, for the ALB perspective, okay, they're not concerned about again the IP of B, C, and D. The concern about if somebody come on slash chat as a path or as a route, which target group we have to connect. Because this target group has some their internal load balancer. It's not visible in the AWS account, but they have some internal load balancer for this target group. Or but if somebody come on slash search, okay, which target group we have to connect, and this target have their own personal load balancer. So if my ELB come to this target group, so this load balancer connect to this guy, this guy, this guy. So this will taken guy is a managed services. Again, everything internal architecture is managed by AWS guys. But internally it look like this. Otherwise, if you see from the portal, lots of things is not visible, everything is hidden. Okay, the way I explain you VPC also, but something like this going to happen. Okay, so it's a good thing, guys. So how it's helpful. Maybe when I go for auto scaling topic, I will explain a little bit more, but how useful. Maybe initially we have one single OS of search, but you see, guys, some more lot of search start happening. You need more computer, more resources. Just go and add one more computer. Go and add one more computer only in the target group. So you don't have to change anything in the ALB or change in the final URL of the client, or maybe in the front end application. Just in the come to the backend and keep on adding more and more same AMIs instances in this target group. That will manage your some advanced load or some more traffic coming for less search application. Or you think there's not lot of traffic coming in the search application, just go to this target group and shutting down this OS to save your money and the cost. Okay, so it is good practice, guys, to it's not a good practice, a compulsory maybe here. Okay, to put your computer in the target group. Okay, so guys, lots of concepts I explained to you. Okay, some of the concepts I just touch very quickly because I don't want to invest my time here, because we are into AWS training, but at least you get the idea what is the use of ALB. application load balancing. So this kind of setup, guys, we are going to do here. So for this, the step-by-step thing is something like this. So first step to implementing this setup, we already has the VPC, we already have the subnet. I'm not going to discuss this part. So first of all, I'm going to launch I'm going to launch one EC2 instance that will have only one application, that is slash chat. Okay, this one. Let me start from here. Okay, then second step would be, after this instance launch, I will put this instance into one target group. Okay, this part will be done. Same step I will do one more time. I will launch one more instance that has application called slash search, this one. Then again, same thing I'll do. I will again put this guy into a different target group. And here, let's say my target group, I'm going to give, let's say, a Linux World Chat. So just a target group name I would like to give. And here I'm going to give the target name called as a Linux World Search. So let's do till here. After target group created with the instance running, then we'll go and configure the ALB, application load balancer. Okay. So let me do it very quickly. So for this, I'm going to launch a new instance. Okay, and I'm going to launch the instance again from the scratch, because my AMI doesn't have that application what I'm looking for. So I'm using the same AWS with one instance. I'm putting in one A data center only. Okay, and obviously we don't need any public IP, the way I explained to you yesterday. So let me disable. I don't want any public IP. Why, I will explain you. Okay, 1 minute. Let me open your document. So I'll share you all the step-by-step process. Okay. So that's all. Storage is not important. Let me give the name. This is the OS for chat one. Okay. Let me chat OS one. Then security group. Right now, guys, I'm enabling all traffic. It's not good practice, but you guys know, to make it faster and clean, I'm doing it. And I'm adding a key here because I have this instance is not configured. Okay, so I have to log into this instance. So by the meantime they launch, let me launch one more instance, same way. Click. Same instance. I'm again putting in the same subnet. Again, I don't need any kind of public IP. Okay, story is same. I'm giving this name is called search OS1. Okay, security group is same, all and all. Review. Let me give this key so I can configure this guy. So two applications, guys, two OS is launched. So according to my steps, okay, this part is done. This part is done. So I'm going to configure this instance also for this particular application, right? So depending, guys, which language you are comfortable on. Okay, you can use your language to configure this guy. I'm going to use very simple HTML language to configure this, or maybe PHP language. So let me go to chat OS first. Oh, I think actually, I did a small, mistake here, because I have to connect to these guys to configure, because it's not yet configured. So I need a public IP. Okay, so I disable the public IP. So if you disable public IP, you can attach the public IP from the EIP. By chance they come with cost, right? But you can attach afterwards also. So by chance this instance don't have a public IP. So what can I do? I can go to EIP. It's called Elastic IP, and here from here you can borrow some public IP. Okay, so I'm borrowing some public IP for a minute. Okay, click here, allocate the public IP. Okay, so I got one public IP, and now this public IP is not associated with any of the OS. So what I'll do in this public IP, I'm going to associate this public IP to one of my EC2 instance. Okay, so which instance I want to connect? So to the chat OS one. Okay. So by chance, if some of the OS don't have the public IP, but you want to use for some time or maybe for longer, so EIP is a concept. Even the name is also elastic. Anytime you can add or remove. Okay, and this is one of the use case. Second use case, elastic IP is what a public IP you guys get in your AWS instance that is dynamic. So after system shut down and start, your public IP will change. But if you add any EIP address, it is also public IP. But if you add any EIP address, it is fixed for you till the time you manually release this guy or disassociate this guy. Okay, so it is a permanent address, a static address. So it is static public address. Okay, so nothing special here. In this chat application, I add one public IP. So I can just connect from my computer, public world. I can configure this guy. Okay, so sorry, I have to connect, guys. So what I'm doing here, very quickly, I'm going to configure this guy as a application. I'm configure Apache Web Server and PHP also. Okay. Otherwise, you can use Python, Ruby, whatever Java, whatever language you guys are comfortable on. Okay, and I'm going to configure, put one web page here. Okay, so if you guys know about Apache Web Server, so in the Apache Web Server, you can change your document root. Okay, but I'm not doing here. So what I'm going to do, you guys know about this folder. There's a by default location where you put all the web pages. But because for us, this is my chat application. So I'm going to create one extra folder here. It's called chat. And all the code of my chat I will put here. So what I'm going to do here, I'm just putting one very simple code with index.php page. Okay, over here. Okay, in this page, I'm going to write PHP code and just type print, and I'll say welcome to chat app. That's all. So nothing special, simple. But the thing is a big application for chatting, right? I'll just give this name. And maybe if you understand, just print your IP also if you want to print. And I think in the last class we got some issue. So let me give the complete path of the ifconfig command. I don't know where it is, which ifconfig. So it's USR has been. So give the complete path. USR has been. Okay. So this application has been created. Good practice to always check. Okay. So I'll use PHP code to check the syntax. No output, everything work good. Very small thing I'm doing here. I'm using PHP. So I'll use some HTML tag inside the PHP as a new line. And one more small thing I'm doing here that we always do. I'm using some pre-tag of HTML. So it will format my output in my browser. Okay. So that's why this is one application we have created. And you can start your service enable httpd -. This is a one command in the Linux. It will make your service permanent enable, but at the same time they will also restart the service right now. The two things this command will do for you in one go. Otherwise there's two command you run. One is for permanent, one for start the service. So this command will do both the things for us. Okay, so by chance guys, in this IP address, okay, in this IP address, if you see guys here, there is no output come up. Why? Because I put my output in a folder called /chat. Okay, and if you right? In this folder I've used, I create this page and also PHP. I can see the output come. But guys, if you know a little bit about web server, okay, index.php is a by default home page. If you type the name, if you don't type the name, it will give you the same output. Same output come up. So technically, according to my current setup, I have one computer, okay, that has a folder called slash chat that contains some my chat app. Okay, that's what we have created. By chance, this is a public IP, but this public IP is not useful. The actual IP of this computer is, I can check from here. Actual IP of this computer is IP, this one. Let's say 52. So 52 is the actual IP. So same way, guys, I'm going to configure one more computer very quickly, same way. Only difference is this computer will have a search app. And I'm going to post the search app in the folder called slash search. Okay. So for this, what I'm going to do, we have one more instance running. But by chance, this instance, I don't have a public IP. So what can you do? Because you already have the EIP, but this EIP, guys, is connected to the other OS. But in the other OS, I don't require intent access. Okay. So what can I do? I can remove the IP from there. It's called the disassociate. Okay. And now this IP is free. And now this IP, I will connect back to my other instance. This called search. And that is the reason it is called Elastic. We can add and remove on the fly. So this is a different computer come up, okay, with the same IP. Now, I will click on the instance, the search. Now we have public IP. Let me now connect to this system. It's a new OS. Let me do the same setup very quickly. So yum install httpd PHP application, Java application, Ruby application, whatever you want to install. I highly recommend those who are following my Python classes, please configure Python APIs or Python CGI. Okay. And here in this folder, I'm going to create a folder called search. Because for the web server, any folder you create in this folder, they work like a path. And for the application layer, this path is the tag. This one slash search tag or slash chat tag, something like this. And in the search, okay, if I have the code open here, I will copy from there. If I have, yeah, I have. So let me copy paste. I don't think so they allow. Let me check, but I don't know. So here I'm going to create a similar code. They're not allowing. So again, PHP start, PHP close, pre-close. Okay, and print welcome to search app. Sorry, print br tag, and just for testing, maybe somewhere we might require, I'm printing usr has been, come on, if config command. Okay, so same code, only difference is the content is different, so you can see the differentiation, right? What happened? Okay, I forgot to put semicolon here. So thing work good, right? And finally, let me start my services and also enable it permanent. That's all. Now, if I connect to this application over here, this IP, okay, I don't have any data, but my data is there in the slash search path. Okay, so this is search app, and this is running on the different IP altogether. So according to my system, this is running on IP 14. So anybody come connect to IP 14, they can access this application. Anybody can do IP 52, they can access this application. But obviously, if you do vice versa, in this IP, if you try to connect slash chat, it won't work because this team, this OS, this application is not managing any chat application. Okay, so there's no application here. So till here, guys, we have done step one. In the both side we have done. Okay, but if you want to do a path based routing, or you want to set up ALB, you have to put this instance in different target group, or this instance, or maybe hundreds of instances of this guy of slash source in different target group. Okay, so now from here there's a new topic start, and maybe this is the first time, guys, we are touching this topic. Okay, topic is in the EC2 dashboard. If you go down, you can see there's a concept called, in the load balancing, we have a concept called target groups. So here, from here, guys, you can create a target group. I don't have any target group with me. Okay, so I'm going to create a new target group. Okay, and in the target group, guys, in the target group, you have to add a targets where your load balancer route the request to. It means you have to add the target. So this is a target group, and these computers are the targets where your load balancer will send the request. Okay, so this target group, what kind of computer we are going to add? Okay, so very interesting use case, right? Behind in this target based computers or instance, do you want to balance the load instance within your specific VPC? Okay, so again, guys, if you see here, these computers is running in my VPC. Okay, VPC is there, subnet is there in VPC, and all the computer in the VPC is running in the AWS data center. It means, do you want to use ALB, or I can say target group, and inside the target group all target from the AWS cloud? Or there's one interesting use case, guys, a lot of guys normally ask, can we use a load balancer for the computer running on premises? Okay, means in my laptop, in my laptop I am running with this computer over here. Okay, so this is called, I can say, on premises, or maybe your company has their own data center. There's not the AWS cloud, and they are running with one VM there. But can you use a load balancer of AWS cloud to send the traffic to this guy? Answer is yes. Only thing, obviously, you require public connectivity to associate with public IP, or do some kind of DNetting in your company router. Obviously, they have an internet connectivity. That's the only thing we require. Or maybe some kind of other VPN connections also. There's a different point, but you got internet connectivity. The point is, can you use AWS um, um, load balancer to connect to the computer, uh, connect to the computer of your local laptop for load balancing? So it is something like this. I can create one web server here, put my some chatting application here, and anybody who connect to the ALB and write /chat, this will connect to IP1, and this IP1 computer is not running in the EC2 instance or by the EC2 instance. It is running in my laptop. Can you do this? Answer is absolutely yes. Okay, for this you have to tell to your, and guys, this is a very commonly used question, right? Not in exam perspective, right, in the real world use case perspective. Okay, so for this you have to create target group that has a capability to put all the computer instances on premises. Okay, and that is the reason, guys, we see there's one option called support load balancing VPC and on premises resources. You have to select this option. And there's some concept of lambda also we will discuss in my upcoming classes. But right now, guys, I'm not showing you to connect the computer on premises. Okay, but this is the one task I just want to give you. I suggest you guys just try to do this task. Okay, and task is something like this: create a load balancer in the AWS cloud. Okay, like ALB here. Create target group, obviously in AWS. But instance that you put or target that you put in the target group would be running in your laptop in the virtual box. Okay, just try it. Obviously, you will stuck. You will stuck um, uh, uh, to having the public IP. because your laptop don't have public, and AWS running in the public world, they won't able to connect. But guys, there's a lot of program available in the market. Some of my training, not in this training, some of my training, I have given you a concept of ng proc, some kind of program. I just forgot the name. Okay, that give you capability that your private IP will convert into public IP. So a lot of VPN and proxy program available in the market. You can use that program. I want at least you guys try this, right? NG Rock, actually. Thank you, Samarth and Poojan also. So NG Rock, NGROK is a program. Okay. So your laptop has a private IP in your instance, and you can use NGROK program or NG Rock program to convert your private IP into public. If you convert into public, then ELB can connect to instance. And this, you can think this instance running on laptop, but you are using the load balancer of AWS. So very powerful concept. Okay, just try to implement it. Otherwise, if you want, I'll show you. Definitely, I'll try to show you if you have some extra time come up in this class. But I just want to give you very interesting concept, very useful. But here, my target type is instances. Means all of my target or my instance running in my VPC means using my EC2. Okay, guys, but this take this as a task. This one. Now, second thing is just give the target group name. So according to my plan, my target group name gonna to be Linux World Chat, LW Chat. Okay, and again, this is a final protocol. You're going to connect to your backend server with my in my target group. So like I said, this is your entire group. They have lots of computer running with the same application, maybe IP 1, 2, 3. But here in all the computer, your application is running or what? S3 protocol. Which port number? 80 port number, or maybe 81 or 8080. So these are backend server. So you have to give the protocol for the backend and the port number for backend. So we know the server we have configured work in this protocol and this port number. That's exactly they're asking the protocol name and the port number. Okay, and again, because we are running all those computer in my VPC, which VPC are you using? So I am going to use the VPC. So I'm using this one, my default VPC. Okay, so that's what we have done. There's multiple protocol version also HTTP. So I'm using the by default one, HTTP 1 or 1.1, I can say. Okay, and health check you guys know. So so the health check path would be, okay, default path of slash ping to the root. Okay, means by default they will ping to the root. Okay, so root here would be slash chat. So in the slash chat, because this application working slash chat, or maybe you can give slash chat index.php, right? So you can give the proper path here, just which page you want to ping. What is the meaning of ping? You guys know what is health check, we discussed already yesterday. Because load balancer guys always use the health check to confirm your target computer or backend server is running or not. If they're running, only they register the target, and a target means your backend server. Okay, so that's a target group. That's all. And now, which computers you want to put in this group? So I'm going to put this instance, but only one instance guy is configured. So I'm going to put the instance called slash chat. Okay, so port number for select instance, obviously they're working on port number 80. So nothing is special here. And so 1 minute. So I have to select, I'm selected, that's all. Sorry, I think we have to click here. So now it is selected. So technically what we have done, one group we have created. And if you see in this group, okay, We have one target. Okay, target is not listed. I think I have to click there. So let me click again my chat one, and I have to click on include as a pending below. Now they have included, and again rest. So in this group, again let me go from here. Now I have one target group, sorry, and in this target group, okay, my type is instance type, means I'm using VPC instances, not my own premises. And here I have included one target, or maybe have hundreds of components, but all the components should have same URL, same port, same protocol, same application. Obviously, they should be same, like chat. The way I explain you, in the Facebook example, somewhere. One minute, please. This one. So when Facebook connect, there might be lots of chat program running or chat application running in multiple systems. But everybody belongs to one target group. Okay, something like this. So this one is done. But if you notice one thing, okay, it has been long now to register this target or backend server to this target group, but still my strategy unused. Why? Because target group just is a grouping. It's just a group. Okay, target group is just a group. 1 minute. Where is my? It's just a group. Okay, so target group we have created, but if you want to use a target group, you have to configure the application load balancer. That part I haven't done yet. Or without the application load balancer, nobody will connect from outside world and to the routing. So you have to connect this target group to this application load balancer. Till that time, you will see it will be unused. But we will configure, guys, this guy, right? Now let me do one more thing. Let me create one more target group, one for my LW search, right? So I'm going to create one more target group again for my EC2 instances in my VPC. This target group is called Linux World Search, same protocol, same port number in my default VPC. Everything is same. Where is my document? So everything is same. Health check, it will go to /search and looking for this page just for checking the health, because the load balancer always check the health. Okay. And which computer I want to connect? This one. So here I am going to connect a different set of computer, maybe one or maybe 100, but everybody have a same final URL and same content or same application. And again, let me include. Okay. And that's all. Two target group has created. It didn't think like every target group has an independent application, or every target group has their own microservice. So again, you can think that I have two microservices running. One microservice is chat, one is LW search. And in LW search microservices, they are running with only one target, one instance. But we can add more if the load increase for search. Okay, so till here, guys, we have done. Only one and last step is we have to create a application load balancer. And what we have to do in the application load balancer, we have to create this one, policies in the listener. Or we can also say a concept called rules in the listener. Okay, that's what we have to connect. So so let me go to, guys, new this step called load balancer. And let me create a load balancer here, and this time I'm going to the application load balancer. So you guys know difference internal and internal. So I want my application load balancer to connect from outside world. So use the internet phrasing. Okay, and let me give the load balancer called Linux World Application Load Balancer. Okay, so this name I'm giving here. I'm going to use the IPv4. Dual stack means you want to use IPv4, IPv6 both. I don't want right now. I just work with IPv4. Okay, and if you notice here in the listener, we don't have any mapping for the port number. If you guys remember yesterday, this screen give me two port number. One port number for load balancer, one port number for instances. And you know what I did yesterday? I did something like this. If anybody, maybe I explain you here. If anybody come on port number 8080, we will connect to port 80. So this is my load balancer port. This is my backend server port. Okay. Why? Because I used yesterday classic load balancer. They work on port based or transport layer based, layer 4. But today they're not asking here because my listener is a kind of process, means one kind of load balancer. They never, as such, they don't see the port number. Okay, port number just they use for connectivity. But according to my plan, we are going to create an application load balancer on this port number. You can use anyone, any port number, because I am going to use my application load balancer with this port number. So let me change here 80, but you can use 80 also. Okay. So if any client connect to my application load balancer on the public IP on this port number, okay, they will do the routing. But my client has to provide one more extra thing. That thing is the path also, which path they want to connect. Only then my application load balancer will check the rule and they do the routing. Okay, but till here we have to configure this. We have to tell one more thing. You have to enable the load balancer for which availability zone. Right now, guys, because all of my target is only in 1A, so I'm enabling my load balancer only for this availability zone. But you think if you have some kind of cross zone setup that we will definitely discuss. Okay, and some of the computer running in 1A, some of the computer running in 1B, you have to enable these two guys. But I can go for five, all the three also. But in my case, I don't require, because all of my computer running right now in 1A. Okay, and global etc. guys, there's a very interesting topic. Okay, I will definitely discuss in my upcoming classes. Independent product, we will discuss there. Okay, so I'm not going to configure right now. Okay. Sorry. So at least two subnet may be specified. They have a constraint because they say you have to follow a good practice of disaster recovery. Okay, so maybe your instance is not running in 1B, but you have to select two subnet. Okay, why? They will maintain the high availability for your load balancer. What I mean by this, when I explain your cross zone, I will explain that point in time. But at least two select you have to do. Okay, this about because my right now my load balancer doesn't working on HTTPS. So all the traffic from the client go to my load balancer of our HTTP is not secure. So they are giving you the warning. That's okay right now for us. Security group, you guys know. So let me create a new security group, and this security group is for the load balancer, because my load balancer working on port number 8080. So anybody from anywhere where in the world want to connect to this port, let's allow. Okay. So I'm going to for TCP and allowing this port from anywhere in the world. This is a guy same example we did yesterday. Okay. Now, guys, can you hold for a second? Now, here they're talking about now very clear. They say you are going to configure the application load balancer. Your duty is to do a load balancing, or I can say the right term is your duty is to do a path based routing or reverse proxy kind of thing. So you have to tell behind you which target group is working here. So if anybody connect to you, okay, which target group you have to connect, this one or this one. So they're asking about which target group. Either create a new one or because we have already created target group, so just click here. And here guys, they give you all the target names, and we have created two targets, so let me use slash chat. Okay, so because we already created a target group, otherwise this screen will give you the options to create a new target group, but we already have. I use existing one. Okay. Guys, if you see whatever I configure my slash chat target group, all the options automatically load here. So we don't have to do much. But by chance this this page will give you only option that if anybody connect to you your load balancer where you send the traffic, which target group. By chance this page is giving the options to add only one, but I have more target group, I have more microservices. So if you want to add more microservices or more target group, so this page doesn't give you the option, we have to add in other way. Okay, how I will explain you. But by chance behind this application load balancer, I add only one application, this called slash chat, or one target group. Okay. So let me go to next. So they say the target group that you select is this one, only running with one EC2 instance. Okay, so they give the name of the EC2 instance. Okay, even though if you see in the top, there's the, if you see 04A, this one where I launch chat. So obviously they are right. Only one we have. That's okay. We have one. But we can add more in this target group in the future if you have more load. So that's okay for us. And that's all, guys. Your uh, application load balancer have completed. So there is no error come up. That's a good thing. This application load balancer has configured for us. Okay, and they say it takes some minute because I'm the application load balancer. I'm going to a target group, and target group we are interested in to connect your instances. So we are checking your instance, they're up or not by checking their health check. If they're healthy, I will connect. After we connect, you can use us. Okay, so now if you see here, one more load balancer come up. That's called application load balancer. And if you notice here in the description, this application load balancer give a one name. This is a public IP. It is something like this. They give one public IP to you. When you connect to this public IP on this port number, you can connect to ALB. But that is not enough. You have to give a, a rule also, slash chat or slash search. This rule also. Okay, but I haven't create this rule. So what happened if I connect to um, this particular IP with the port number 8080? What happened? Some test page come up. As such, there's no error, right? But if I type slash search, they say not found. If I type slash chat, output come up. Why it is happening? Because while configuring this ALB, I have connected to only one target group, and the name of target group is slash chat. And in this target group, we have put this application in this URL, so thing is working for us. Okay, and by chance they have only one computer, so they are always going to this one computer only. If you keep on refreshing, they are only going to one because we have only one target. But if you have more target, automatically guys, they will create a load balancer for you, so they will balance the load. Okay, but this what not we are not interested in, because same thing we can do with classic load balancer also. We are interested in other things. What we are interested on, right? Just by using one single endpoint, like Facebook, if we click slash chat, they show me this output. They're showing me, and if I click on slash search, just by changing the path or the route name, okay, they will connect me to the different application running in the running in the different computer. But internally, you know what they're doing? They actually again connect in the same issued instance, and they say in this instance we don't have slash search app because we haven't configured there, so they say page not found. Okay, but I don't want to connect create the slash app in the same instance. If you connect both the app in the same instance, so there's no meaning of proper microservice management. So what I want in my ALB, okay, if somebody connect on slash chat, they will connect to different target group. Somebody connect on slash search, they will connect a different target. So we have to create this kind of policy and the rule, and that is managed by listener. And how we can connect? So for this, when you create when you go for your application load balancer, if you see here, this is the application load balancer. Okay, as an internet facing, there's a reason we can use from the outside world, but here if you see, there's option called listener. And now you can see some difference here. Okay, if you go for CLB, in the listener we have only option of port number and port number. Okay, if you go for classic load balance. But if you go for ALB, okay, in the listener, the rule doesn't has any SS port number, but here in the listener we have option for rules. And what the rule is saying, the rule is very clear. They are saying if anybody come to this um, application load balancer on their public IP, on the DNS IP, okay, and come on this port number via this protocol, okay, we will follow these rules. Okay, we will follow these rules, whatever rule you have created, and you will create. Okay, we will forward to this rule. See here, we will forward to this rule. And what those rule contain right now, if you click on the view and edit the rule, okay, so this is a page of the rule. And what this rule contain only one thing. If anybody come on this protocol on this port, this is the by default rule. I can say this is the by default action my load balancer will do. And they say we will always forward you to the LW chat target. Okay, and what is the LW chat target? This one. They will always forward to this guy. So this is a by default rule. By default means if nothing is matched, this is the and last they will always connect to this guy. That's what guys they're doing here. That's what they're doing here. Here, wherever I have opened this page. 1 minute. They're doing here, not here. In my, I don't know which page I have opened. Here. So they're going here. They won't find, so they find not found. But what I'll do here, I'm going to add in the top. There's a plus icon. I'm going to add one more rule. I still put plus, and I'm going to insert one more rule. And rule is very clear, very clear. I wanted to say, if anybody, what's my plan is, right? I would like to add a rule where I say, if anybody come to slash chat route or path, then connect to this target. Anybody come to this part, connect to this target. Okay, that's what we are going to do. So anybody come to a path and the value of path is slash chat. Okay, then the final action is you have to forward to a target group, and name of target group LW chat. That's all. Okay, so anybody come to slash chat path or the route, connect to this target group, and this target group, you have one computer or 100 computer, they will have the internal load balancer. They will balance the load because every application should be same there. Okay, so that's all guys, this rule is created. So let me tick, select and select and save. Okay, so one rule we have created, but now we have some more microservices and some more application, even though this rule we don't require because we already have this rule. Okay, but normally the last rule we always create something other. What I mean, but I will tell you. But let me add one more rule. Okay, insert the rule, and here again the rule is same path, and here the path is slash search. So anybody come on slash search, again I will forward this guy to a different group. That's all. Different group. Now let me select this. Let me select this and save this. Now, technically, what I did in my application load balancer, I create the rules or policies. Here, the rule, something like this. Okay. Now, what happened? Now, IP is fixed, port number is fixed, public IP is fixed, port number is fixed, but client will decide which application they want to connect here and here. And normally in the Facebook world, client never type the IP address. Instead of IP address, they type click here or they click here, something like this. Okay, but internally the dial-up of this page, say if somebody click here, I will connect you to slash chat applications or target groups. If somebody click on the search, I will connect to the slash search target group, and they have one or hundreds of server running there. Okay, and this rule has been completed. Okay, and let me go out. So if you see here, again, anybody who come to my IP address of this public IP on a port number, they send a request on 8080, we will check again the same rule, but now this rule has been enhanced. For this path, connect to this target group. For this part, connect to this target group. Now, sorry. Now what happened? Now when I go to my computer again, so if I go and connect to slash chat, you can see chat app open. That's great. It was also showing you in last, but if I connect to slash search again, if you notice guys, in the slash chat last time they connect to IP address 52. Okay, 52, and the 52 is a very different computer running maybe in a different zone, also different computer managed by different team, but they connected here because we connected to slash chat. But client, if you use the same URL and same port number and the type slash search, still they're showing not found. Why are they showing you not found? Let me check. Student, maybe some small uh, mistake I have done, and the step maybe okay, step maybe because normally we say only slash search if they come up with. But right now, guys, I'm not connected with slash search. I have connected with slash search index. Okay, and if you, even though if you write slash search, actually they write one slash here. The slash means your home page. Okay, so technically there's difference between slash search and slash. Okay, so what can we do here? I have to again go to edit rule. Okay, I have to edit this rule, and this rule I have to edit, and let me delete this one, add a condition again, and actually the path should be not slash search, it should be slash search star or maybe slash star, something like this. This will be better because in slash search there might be multiple pages. Index.php, I have single page, but there will multiple pages. Same thing for this guy also. Update. I think this is challenge, I believe. So slash chat star. Okay, and update. So anybody come to slash search dot index dot php, something like this, connect to this guy. I think this is the challenge, I believe. So, but in the chat, why I was working? Because we actually already create a default rule. They always go to slash chat. Okay. So if I again search slash chat, same output come up. That's nice. But if I go to slash search, now they're working gracefully, powerfully. Okay, again, understand guys, I think it is like a one Facebook app. Okay, but if somebody connect to slash search, they will create entire different set of computer or the microservice here. Welcome, and this computer they're connected, that's called IP4. Means they have a capability to go to the HTTP header, or it's called application header, and check what is written inside the header as a path. And if we write slash chat, they will connect to the slash chat. Okay, so that's how it will work. And even though guys in the rule, there's a better way to write the rule. I can say instead of the slash star, okay, you have to write slash search slash star. Okay, what I mean by this, let me write the rule update. Okay, and what I'm talking about now, if I have this, this will come up. Why I'm doing so? Because if in the last rule, if somebody type slash searching also, slash searched also, so because I write slash star, it means all the pattern will match. But I don't want this. I want, if anybody come to slash search, then slash something inside index.php, all the things, they will connect to search app. So that's the reason the best way to write here is slash star, and similarly, the best way to write here is, so it's something like a pattern matching. I'm doing it. Okay, so this is a better way to write. But if you notice here guys, anybody who by chance know web technologies, okay, so there's lots of rule we can create. Okay, related to HTTP header, request method, query string, host headers, especially in the query string, right? So it is something like this: somebody checkout in the in e-commerce sent to this server, somebody's create a a cart in the application, just connect to this computer, and somebody have already transaction purchased the item, sent to this piece. If somebody is searching for some products, so sent to this servers. So query string is a very commonly used thing. But if you know a little bit about web technology, or you can do lots of things with the query string. Okay, so maybe I will talk a little bit more about application load balancer, but the core concept of the application load balancer I explain you. And very quickly, let me go to target group. And this is a target group I was using. And now in this target group, we have one instance target. Now as you can see, now it is healthy. Last time you saw, so it was unhealthy, or sorry, unused. Now it become healthy because some of my ALB using this guy. Okay, and guys, by chance this is a load balancer, IP is public, so you, if you guys want to use also, you can also type. So if you type this IP anywhere in the world, right, and slash, if you write slash chat or slash search, you will also see the output because this is internet facing. Okay, so guys, I have given you lots of basic knowledge plus a very great use case of the microservices. How can you use the load balancer of AWS to do the load balancing of the microservices? So a lot of information I have given you. Some more information I also wanted to share with you about the load balancer. So I might go half more class, maybe one class, okay, about the load balancer or the target group we will do in my next class. That's on next Saturday. Okay. So that's all guys for today. Any queries, any questions you have? Okay, you can ask me. Uh, yes, guys, ELB service is free in your free tier with limited transaction. Only ALB is free, CLB is free, but if you go for NLB, network load balancer, right? I think in a free tier they don't have a free, they will charge you. But again, I suggest just go to free tier and check the list, whatever you have free. Okay. What is the difference with redact or the forward? Pradeep, there's a huge difference actually. So right now I'm not discussing Pradeep, but I suggest to uh, just go to HTTP protocol and search for 301, 302. There you understand the meaning of forward, and there you might also get a reference, a link of redact. Okay, so I suggest just go there. You're teaching very slowly. Yes, Ankit, maybe, but the pace is actually very depend upon your previous knowledge, right? Maybe you know some of the concept of networking, so for you it's slow. But anybody who are very new in the concept about load balancing, so for them. it might be okay speed. So okay, we can only chat target group in ELB, so we need to add search target. Yes, yeah, I show you. I think this discussion we have already show you. Explain the use of star. Star here means any. So you know what I write in my rule? I write something like this. I write something like this uh, in my rule. The rule is slash star. So anybody from my client, if they type slash search and then slash in login.php, or maybe items, or maybe people, whatever they write after the slash, we always send all the requests after this path to only this target groups. Because service application, you don't have one single page, you have 100 pages. But all the 100 pages we will send to this guy if they start with the slash search. So uh, can we achieve same thing using CLB, like one port number for other service? Yes, you can achieve IOS, but this kind of planning of path, you can't achieve that. Only port based you can do, and normally we don't launch multiple ports in the. There's a lot of other reasons also in the for the public facing. One IP, one URL, one endpoint I need to to do a redaction, means connect to multiple server, multiple targets. Static IP mobile means it won't change, it is fixed. So what is query string? Even we are not discussing here, I suggest you go to my Python API or CGI classes. I explain you there in detail about query string. uh, uh, Pramod, if you want to use ng rock with Hadoop, it won't work in this way because Hadoop will use multiple port number. So you have to map all the port number. Not so a little bit complex there in the Hadoop world, because ng rock will give you one side connectivity, not the both the side, right? So what I mean by this, I'm not discussing here. Okay, but ng rock you would be harder actually, I can say, to use in the Hadoop cluster because there are a lot of port number per node we use in master and the slave. Can we do the same thing virtual machine Docker? I don't know which talking thing you're talking about, but but uh, uh, if you're talking about on-premises setup, answer is yes. You can use virtual machine Docker both for on-premises connectivity. can application load balance can handle DOS or DDoS attack? Yes, actually, this is the managed service. So a load balancer, respective any DOS attack or DDoS attack, is being managed by and set up by AWS guy. Even though there's some more service available in the AWS where we can enhance some more extra rule. If you think your company and corporate are getting some kind of DDoS attack from some country or some application, some kind of signature they are using, you can add on the top of load balancer. Otherwise, um, uh, AWS managing the DDoS or distributed denial service attack for us because this is the managed service. Okay. Um, can you please repeat the last 3 minutes I missed? Himanshi, which topic actually you're talking about? Okay, I don't know which topic, but if you're talking about this one, this is the last one. So I said because search app is not the is one app but contain multiple pages. So I want anybody come to my IP, my port number in this path. In this path, they might be connected to item page or login page or any other page. In all the cases, they actually wanted to connect to my search app. So connect to this target group. That's what I explained you in last. So Anuj, I think in my earth class I have told multiple time, don't think it is overload. It look like, but same thing will repeat multiple time in multiple angle. After this thing repeat 2 or 4 times, 5 times, you feel it is interesting that you said, but you also feel now it looks very simpler to you. What is different GitHub and Bitbucket? Nisha, I think we have workshop, right, in GitHub. I will explain you in very detail over there. So so I'm guys trying to pick some of the, because I've seen same question multiple times. One more please. What we have to do with the target group in log. I think Subhasri, I have explained this thing already to you, but don't worry guys, target group gonna use multiple time in the future. But target group is the way to manage the thing. Same set of computer like chat, maybe have 100 computer chat server, we put in one group. That's called target group. Okay. Somebody asked me Elastic IP. If you guys understand one thing, Elastic IP is not free. Even though you have a free tier account, they will charge you per monthly basis, something like this for the Elastic IP. So Elastic IP is not free. Okay. So if you want to test, you can test your choice. It is very cheap, I can say, but it's not free. um, Again, Prakar, Elastic IP actually associated with the same concept with the internet gateway technically. Okay, and the same concept what I explained you in my inter gateway, same thing happen actually behind the scene, but it's not visible from the VPC portal. Okay, they show you that it is a part of your instance network card or instance, but internally, again, Elastic IP also associated with the inter gateway, and they do the netting for you behind the scene. Can we do a multiple public IP with same instance? As such, there is no great technical use tabis here to have multiple public IP. Okay, maybe if you know a concept called theming, if you know by chance networking, maybe you might asking, that is a use case, but Amazon will take care of those part to you, so there is no meaning to attach multiple public IP to one instance. So ALB are your parent DNS name. Chirag, actually AWS maintain one DNS for us. How they manage their service called Route 53, I will discuss there. What is ARN means AWS? Ria, Zudin, every resource in AWS has a unique name. I will discuss. I have great discussion on ARN when I go for IAM policies. So there we have to use ARN a lot. I will discuss about ARN there. So, so I think guys, there may be some more questions. If you guys practice once, maybe you stuck, but if you practice, a lot of your concept will automatically clear of this application load balancer. Okay, and uh, somebody say me, please correct me if wrong. I think not network load balancer work on transport layer as it is a TCP load balancer. Yes, Vishal, you are right. Finally, network load balancer is also have to have to connect finally with the port number. So it look like a TCP load balancer. It look like okay, but it is optimized. It is optimized to process only the network layer. Okay, even though if you use network load balancer also, they will also process your application header also. So technically the entire header has been processed. It is not like, it is never like this. Technically your program is only use one layer, network layer or data link layer or application. The entire all the 7 layer or 5 layer or 4 layer going to be used. Okay, but program is optimized for what purpose and what data they are retrieving from from the header. Accordingly we tag the name network based or layer 3 based, layer 4 based. So finally, they are going to balance the load of TCP only because they use TCP application also, but they are optimized to process only layer 3. That is a reason we we say uh, this called network load balancer or network layer based load balancer. Okay, I think Vishal, I just trying to give you what you asked me. You said what you said is right, but internally, all the layer has been processed technically. So, so that's all, guys, for today. For today. See you guys tomorrow, and sorry, in the next class we'll talk more about load balance. Okay, don't worry. This concept again will repeat in some other form and some other way also we are going to use this. Going to use, so it will be again repeated. Okay, and that's all. Yes, Bharat, my ELB topic is not complete, so we have some more discussion. CLB, ALB, and NLB also we will discuss in the next class. Don't worry. I might go half or maybe one class more. That's all, guys, for today, and see you guys in the last class. So next class. Bye. See you.